What's up everybody, and welcome to a new video. And in this video we're going to go over my notes for scopes in Python. Namely, variables can exist in three different scopes. They can exist in the global scope, the non-local scope, and the local scope. And here I also have an illustration that shows how those different scopes relate to each other. So the innermost scope is the local scope, then comes the non-local scope, and then lastly here the global scope. Okay, so now let's go back here to our notes, and let's first cover my notes here for the global scope. Namely, there's only one global scope, and it gets created when the program begins, and it gets destroyed when the program ends. So for example, if I say here global x, and if I set that equal to 1, and then if I print out this global x, then we get here a 1. Now, however, if I restart here this Jupyter notebook, which is basically like ending a program, and then if I now try to print out this global x again, then we get here this name error because name global x is not defined. So this global x here that we've created previously doesn't exist anymore, and that's because that previous global scope was destroyed when we restarted here this notebook. Okay, so this is then the global scope. Then let's next cover the local scope. Namely, this exists within a function, and it gets created when the function is called, and it gets destroyed when the function returns. So to demonstrate that, I've prepared here this function. So within this function, we simply create here this local x variable and then print it out. So now if I call this function here, then you can see that it prints here the 3. However, if I now here try to print out the local x, then we again get here this name error because name local x is not defined. So local x here doesn't exist anymore because it got destroyed when the function here returned. So that is the local scope. And then lastly, we have the non-local scope. Namely, when you define a function within another function, then the non-local scope exists within the outer function, and the local scope exists then within the inner function. And it gets created when the outer function is called, and it gets destroyed when the function returns. So to demonstrate that, I've prepared here this function. So this is called outer function, and here we create this variable called non-local x, and then we print out that variable, and here we define then the inner function. So now if I call here this outer function, then you can see that it prints out here this 2. However, if I now try here to access this local x, then you can see that again the name non-local x is not defined, and that's because this non-local x here was destroyed when this outer function here returned. Okay, so those are then the 3 scopes that are available. So now let's go over these side notes here. And the first one states that a variable only belongs to one scope at a time, i.e. it can't belong to several scopes at the same time. So to demonstrate that, I've prepared here this code snippet. So here I define x to be equal to 1. Then I create this function here, and then here I print out x. So here I would like the function to print out here this global x, because from within functions you can actually reference global variables. But we will talk about that in more detail when we talk about here the reference behavior. Then here on the second line we then set x equal to 2, and then here we again print x out. So this time it should print out this 2. So what this function should do is print out x, so print out the global x, and then here print out x again, where we have then the 2, which is then here this local x. So now if I run the function, then you can see that we actually get here an unbound local error. And that's because we cannot access the local variable x where it is not associated with a value. So Python actually considers this x here to be a local variable, and because we haven't created it, we can then therefore also not print it. So that this is basically the same as saying here print y, and then here we only define y. So in this case then we get here this name error because name y was not defined yet. Okay, so that is the first side note here that I wanted to cover. Then the next side note is about one specific reason for having different scopes, and that reason is to avoid accidentally overriding variables. And the example that I want to show that with is the following. So let's say that you try to code the breakout game. So therefore, I've prepared here this code snippet. So here I'm creating in the global scope here these two variables, so width and height. And then here I'm defining this function, which is called adjust platform width. And then within this function, there is this local variable, which is also called width. And then we set that to a specific value. And then here, when we call this function, then you can see that it returns here a 12. However, if I now print out the width again, then you can see that it is still 250. So this global variable here, this global width, wasn't overwritten just because we are used here in the local scope also another variable that was also called width. So that is one specific reason for having different scopes. And then the last side note states that technically there's a fourth scope, namely this is called the built-in scope, and this is the outermost scope. So if you look here at this image, then you can see that this built-in scope is actually here the outermost scope. So if you then go back here to our notes, and this built-in scope here contains, as the name suggests, built-in objects. So for example, it's functions or exceptions. And normally you don't create variables in the scope. However, Python references it if it can't find a variable name in the local, non-local, or global scope. So for example, if I simply say here print and then hello, then you can see that it actually prints it out and we don't get an error, even though in our global scope here, we have no function defined that is called print. So this print function here lives in the built-in scope. Okay, so with that now, we've covered here all the side notes. And with that, then we've covered here all my general notes with respect to the three different scopes. Then the next note is about referencing behavior. And here, the first note states that inner scopes can reference the variables of outer scopes. However, that is not possible the other way around. And here I also have an illustration for that. So let's open here this file. So here, as you can see, the local scope can reference the variables of the non-local scope and also of the global scope. And the non-local scope can reference the variables of the global scope. However, that's not possible the other way around. And to demonstrate that, I've prepared here this code snippet. So here we are creating global x. So this is a variable in the global scope. Then we define here this outer function. And within that function, we create here non-local x. So this is a variable in the non-local scope. And here we say that this is equal to global x plus 1. So here we are referencing here the global variable. And then here, next, we define here this inner function. And within that, we create here local x, which is then a variable in the local scope. And here we say that this is equal or should be equal to non-local x plus 1. So here we are referencing then this non-local x in the non-local scope. And then lastly, within this outer function, then we call here this inner function. And then lastly, in the global scope again, we call then this outer function. And now let's try to print out all those different variables here. So we're going to say print global x, then print non-local x, and then lastly print local x. And now if I run this, then you can see it prints out the 1. So we could access here the global x. However, for non-local x, we get here this name error because non-local x is not defined. And that's because from the global scope, we can't reference here variables in the non-local scope. And that's also true for this local x. So let's comment out here the non-local x and now try to run this again. Then here again, we get this name error because local x is not defined. And again, we get this error because we can't access here or we can't reference here the local scope. Okay, so now let's put those print statements here into the outer function. So at the end of this outer function. And now if I run it like this, then it prints out here 1. So we can reference here this global x. It prints out 2. So we can reference also the non-local x. However, for this local x, we are again getting here this name error because the local x is not defined. And again, that's because we can't reference an inner scope. So for the non-local scope, we can't reference the local scope. And now lastly, let's put those print statements into this inner function here. So here now, if we run it like this, then we get here the result 1, 2, 3. So we can reference the global x, the non-local x, and this local x. Okay, so this is then the first node that I wanted to cover with respect to the referencing behavior. Then the next node states that a local scope can't reference the variables of another local scope. And here again, I have an illustration prepared. So let's open that. And here, as you can see, we have the global scope and then these two local scopes. And the local scopes, they can reference the variables of the global scopes, of the global scope. However, they can't reference the variables of another local scope. And to show that, I've prepared here this code snippet. So here we have function 1, and here we define x to be equal to 1, and then we call function 2. And then within function 2, we simply try to print x. And then here at the end, we call function 1. So now, if I run this, then you can see that we get here a name error because name x is not defined. So within the local scope of function 2, we can't reference the variables here of the local scope of function 1. Okay, so that is then the second node that I want to cover with respect to referencing behavior. Then the next node is about modules and packages. Namely here, the global scope of a function is the respective module where the function is defined and not where it is called. So to demonstrate that, I've prepared here this file called some module. So here I'm defining module x, and this is set to 99. Then here in function 1, I try to print module x, and in function 2, I try to print the global x. So since this module here is in the same directory as this notebook here, we can import here these functions. So therefore then we can simply say from some module import function 1 and then also function 2. And then here in this notebook, let's create a variable that is called global x. And let's set that equal to 1. And now let's call function 1. So function 1 tries to print out module x. And if I run this here, then you can see that it prints out here this 99, even though in our global scope here of this notebook, we have not created a variable that is called module x. However, we can nonetheless print it. And again, that's because the global scope of a function is the respective module where the function is defined and not where it is called. So the global scope of function 1 is this module here and not this notebook. So now let's do it the other way around. So let's try to call function 2 where we want to print out the global x. And here we get this name error because the name global x is not defined, even though here we've created a variable in this notebook in the global scope that is actually called global x. But again, the global scope of a function is the module where it is defined and not where it is called. Okay, so that is then the third node that I want to mention with respect to referencing behavior. Then the next node states that variables in different scopes can have the same name. And in that case, then Python checks which one is referenced by going from the innermost scope to the outermost scope. And to demonstrate that, I've prepared here this code snippet. So here then in the global scope, I'm saying that x is equal to 1. Then within this outer function, I then say x is equal to 2, which is currently commented out. Then within this inner function, I say then here that x is equal to 3, which is also commented out. And then lastly here, I print out then simply x. And then I call the function, the inner function, and then also the outer function. So if I run the code like this, then it prints out this 1. And that's because what Python does here in this inner function, it first checks if there is an x in this local scope, and because it can find an x, it then goes to the non-local scope and then checks again if there's an x, and again it can find one, so therefore then it goes to the global scope where it finds this x, and therefore then it prints out here this 1. So now if I uncomment this x here and then run it again, then now it prints this 2, and that's because again it can't find an x in the local scope, so therefore then it goes to the non-local scope where it finds then this specific x. And then lastly, if I also uncomment this, then it prints out here the 3, because now it finds here this x in the local scope. So that is then the fourth node that I want to cover with respect to referencing behavior. And then the last node is just a general guideline. Namely, if a variable of an outer scope should be available within the function, then the code is clearer when you simply put that variable into the function as a parameter or argument, instead of just referencing it within the function. So to show what I mean by that, I've prepared here this code snippet. So here we have x, which is equal to 1. Then here we define this function called add x, and here we simply return number plus x. And even though this works here, it is not really recommended, because in a bigger file or in a much bigger function, it might not be really clear where this x here is coming from. So a clearer approach would be to simply put this x here as a parameter into this function definition, and then also put it here as an argument into the function call. So now if you run it like this, then we also get here the same result. However, the code is a little bit easier to understand. Okay, so that is this general guideline, and with that we've covered now all my nodes with respect to referencing behavior. Then the next node is about assigning behavior, and here the first one states that to assign a value to variables from outer scopes, the global or non-local keywords are needed. So first I want to show here an example with the global keyword. So therefore I've prepared here this code snippet. So here I set x equal to 1, and then I define this function where I set x equal to 2. And now what I want to do is here print x, then I want to call this function, and then I want to print x again. So now if I run it like this, then it prints here the 1 twice. So this assignment statement here in the local scope didn't affect here our variable in the global scope. However, if you actually want to change here the global variable within the local scope, then you need here this global keyword, and then you simply specify which of those variables within the function should be global. So in our case, this would be then the x. So now if I run it like this, then it actually prints out here 1 and then 2. So this assignment statement now actually changed our global variable. Okay, so that's the global keyword, and you can also do the same thing with the non-local keyword. So therefore I've prepared here the similar code. So here within the non-local scope, I create this x. Then here in the local scope again, I say x equals 2. And then here I print out x, call the inner function, and then print out x again. So if I run it like this, then again it prints out just here the 1 and the 1. So this assignment statement here didn't affect our variable in the non-local scope. However, if we actually want to change that, then we need to use the non-local keyword, and then again specify which of the variables should be non-local. So in our case, that's then x. And now if I run it like this again, then we get here the 1 and 2 again. So this time then this assignment statement here actually changed our variable in the non-local scope. So that's the first note that I want to mention with respect to assigning behavior. And then the next note is again just a general guideline. Namely, this states that instead of using these keywords, simply pass the variable into a function as an argument, modify it, and then return it. So in this example here, where we use, for example, here this global keyword, we can also delete that. And then here in the function, when we define the function, we also pass in here an x as a parameter. And then here we say return x. And then here, when we call the function, we simply say x equals this function. And then we also pass in here an x as an argument. So if I run it like this, then we also get here printed out 1 and 2. And the same thing also applies here to the non-local keyword. So we can also get rid of that. And then here say x, and then return the x. And then here when we call the function, we simply say x equals inner function, and here we pass in the x as an argument. And then if I run it like this, we also get here printed out 1 and 2. So those are then all my nodes with respect to assigning behavior. And with that, now we've covered all my nodes with respect to scopes in Python. So we've reached the end of this video. And then in the next video, we're going to go over my nodes for recursion in Python. So thanks for watching, and hopefully I will see you in the next video.